Okay, this is lesson 5.4, geometry on triangle mid-segment theorem. So we got some more vocabulary for you. So the triangle mid-segment, by definition, is as follows. It's the segment that joins two midpoints of sides of a triangle. So you have a triangle, it has sides, you find the midpoints of those sides and you join them together, you have a mid-segment. So we're going to go ahead and take these three equations that are here and we are going to graph them and it's going to make a triangle. So these two are relatively easy. Let's start with those. X equals 2 is a Vux line and it's going to be just a vertical line on the 2. Y equals -1 is a horizontal line. It's a Hoy line, zero slope, and it goes along -1. And then the last one, y equals 1/2 x plus 3. We can plot that by finding the y-intercept and then using our slope 1/2 to find points on the line. So we have a point here, 1/2, 1/2, 1/2, 1/2. So we've got that line. All of these have little arrows on them. Okay, and then let's go ahead and identify the vertices. So here's one, here's one, here's one, and let's go ahead and label those A, B, C, and find their coordinate pairs. So A, you should be able to do this without my help. A is 2, 4. B is 2, -1. And C is -8, -1. Now, how about you do C and D? Try to do that without my help. You can hit pause and do that. Remember, to find the midpoint, we're going to do x1 plus x2 divided by 2, y1 plus y2 divided by 2, and the distance formula, x1 minus x2 divided by 2, or squared, blah, plus y1 minus y2 squared. Okay, so try that, and you can do C and D activities without my help, and I'll come back and we'll check answers. Okay, so when you find the midpoint of A and B, you should have ended up with 2, 1.5. And we're going to go ahead and label that X. And so I'm going to do 2 and 1.5. We've got a point right there. That's our midpoint, and we're going to label that X. And then when you did the next midpoint, you should have ended up with -3, 1. And so let's find that. -3, not negative, it should be -1, excuse me. -3, -1 is right here. Let's label that Y. And the third one is -3, 1.5. And so we go to -3, 1.5. And we're right here. We'll label that Z. Then when you use the distance formula, AB, that side is pretty easy because all you have to do is count. You don't really have to use the formula. It's 5. And then BC, that one's easy too because it's a horizontal line. All you have to do is count, and that equals 10. But we do have to use the distance formula for AC, and so we end up with, when you do x2, subtract the x's, you get 5 squared plus 10 squared equals x squared. And so we end up with 125 equals x squared. And so we have to find the square root of 125. And if you've got that, that's going to be square root of 25 times 5, which is 5 times square root of 5. So there's your distance of AC. 5 times the square root of 5. Okay, now let's look at the next two activities that we have to do. Okay, so this next thing says connect the three midpoints to form a triangle. Then use the distance formula to find the distance between the consecutive midpoints. So let's go ahead and do that. And it appears that one of my midpoints has disappeared, which was x, right there. Okay, so let's go ahead and connect our midpoints. So here's a connection from z to y, and then from z to x, and from y to x. And so now we have this little triangle in here in the middle. Isn't it beautiful? And we want to find the distance between these consecutive midpoints. Okay, so we're going to have to use our coordinate pairs for the midpoints again, and you should be able to do that without my help. So get started, and then I'll come in and help you with it, okay? But get going on that. Okay, so finding the distance for YZ, again, that one's easy because it's not on the diagonal. It's 2.5. XZ, again, you can just count. It's the distance between X and Z is 5. XY, on the other hand, is a little more tricky because we have to use our points, and so we end up with the following. So we're going to do x minus x, so you have negative 3 minus 2 squared plus negative 1. Hang on a second. Let me try that again. I was having a little technical problem there. So then we have negative 1 minus 1.5 squared, and we're going to take the square root of that. So we end up with 2.5 squared sorry, I just did that y's instead of x's. We have negative 5 squared plus negative 2.5 squared. So you have 25 plus 6.25, and that makes 31.25 squared. Yuck. Okay, well, 31.25, if you were to take that and put it in math fraction, 31.25, you would find that you end up with 125 over 4. So, and all of this is going to equal x squared, right? So, we want to take the square root of that. Square root of 125 over 4 is going to be, we can split that to 125 over the square root of 4. So, do you remember from our last distance one, 125 was 5 times the square root of 5, and the square root of 4 is 2. So you get 5 times the square root of 5 over 2 for the distance of x, y. Okay, I hope that was clear enough for you. Okay, so now it says calculate the slope of each midsegment and its corresponding opposite side. So let's look at all our midsegments. Our midsegments are AB and the side that corresponds with that, meaning it's kind of in the same position, is going to be YZ. So we're going to get the slope of those two. Then we're going to get the slope of BC. And you know what, let me put my little slope markings in here. Yeah, like this. We want to get the slope. And then we're going to get BC slope. And its corresponding side on the mid-segment is XZ, or ZX. And then finally we're going to do AC. I'll do it in green. And its corresponding side is XY. So let's find the slope of all those things. Well, of course, AB has undefined slope, and we're going to use this little null symbol for undefined. Undefined slope. And YZ, what kind of slope? Undefined. Then BC has what slope? It's a horizontal line, has 0 slope. And XZ has what? 0 slope. And then AC, it has a slope of, let's look, when we do AC, well, we know when we did the line, remember it had a slope of 1/2, and XM, let's check it out. We go, we have a slope of rise over run, 1/2, 1/2, so still the same. Bada bing, bada boom. And so let's see what we notice. Let's see some things that we notice here. Look back on what you had for letter D on your distance. So on letter D, we had AB was equal to 5, BC was equal to 10, and AC was equal to 5 times the square root of 5. So let's notice, when it comes to the distance, the corresponding segments, one was 5 and the other one was 2.5. The first one was 10 and its corresponding segment is 5. And on this one was 5 times square root of 5 and the other one was 5 times square root of 5 divided by 2. So what do you notice? The distance is exactly 1/2. And then when we look at the slopes, we see that same, same, same. So your corresponding mid-segments have same slope, which means they're what kind of lines? They're going to be parallel, and their distance, they're going to be exactly, the measure of them is going to be exactly half of the corresponding side. So I hope you understand when I say corresponding is the one that matches. Here's one that's going this way, so it matches this one. And here's one going this way. It corresponds with this one. And then this diagonal one, the hypotenuses correspond. So there you go. So now let's move to the next page. Okay, I think that just turned off. Mid-segments are parallel and half the length of the corresponding opposite side. Just a little bit of review from the front page. Okay, so let's take a look at our first example here. We're going to use those properties and apply them to some problems here. Okay, so it's going to be up to you to do your drawing, but I did one on my paper, and I went like this. I can't really do it exactly here on the iPad. And then went up this way and did B, and then I came down this way. And so when this doesn't look at all like the drawing on my paper, but you're just going to have to trust me. When I measured it, I had this side was 9 centimeters, and this one was 6.8 centimeters, and this one over here was 7.2 centimeters. Then I use compass. So you have your two segments here. Set your compass a little more than halfway, and then because we're told to construct it, I went like this, found the midpoint. Did it again over here, two segments, set the compass a little more than halfway, and then you go like this, and you find the midpoint. And then do it one more time, two segments, like that, find the midpoint. So you need to get it exactly, and then once we've done that, we can connect them up. I'll do that in orange so you can see it. And there's our mid segments. And so I'm going to label those X, Y, and Z. And when I took my ruler and measured it, I ended up with 3.4 centimeters right here, 3.6 centimeters right here, and 4.5 right here. Amazing. So what do we see? That AC is parallel to ZX, and their distances are exactly half. And then AB was parallel to YX, and when you measure them, the distances are exactly half. BZ parallel to ZY, and the distances are exactly half. Okay, so hope you're good with that, and hope you tried it yourself and used your compass and did it accurately and were able to figure it out. Okay, let's go to example 2. And on this one, it says find X and Y. And so what we have to notice is that Y, well, let's look at the picture. We have two segments that are corresponding, and they are congruent, and then these two sides are corresponding and congruent. So what can we conclude about that? We know that this and this are midpoints. And so Y is a line that's connecting midpoints. And since Y is connecting midpoints, we know that Y is a mid-segment. Y is a mid-segment because it's connecting midpoints. So that's the real clue that we need. We also know that since it's a mid-segment, mid-segments are always parallel to their corresponding sides. So we know that this side is parallel to this side. So, using what we know about mid-segments, let's answer the question. Since Y is a mid-segment, we know that the distance of Y is exactly half of its corresponding side. So Y is equal to 6. And then we know that since these two lines, let me go like this, I'll just kind of extend it like that. Since we know those two lines are parallel, then we know that this angle and this angle are same side interior angles, and so we know that X is going to be 115 degrees. And let's justify that, because if two lines are parallel, then same side interior angles are supplementary. Or, in other words, they equal 180 degrees. Okay? So, good. Math is cool. Let's go into example 3. Okay, on example 3, it says A, B, and C are midpoints of the sides X, Y, and Z. And so we would know that this is true. And not that that's necessary for this problem, but I just want you to get in the habit of thinking about that when the two segments are congruent, then you're at midpoints. Okay, now it tells us that BC has a measure of 3m. That's the distance, so it's 3m right there. and xy has 4m plus 10. So let's think about this. These are corresponding sides, and we know that this is a midsegment, and so a midsegment, the distance is going to be exactly half of what its corresponding side is. So we can set this up and say 4m plus 10 is going to be equal to 2 of the other side, because it's half the distance. So if I multiply it by 2, they should be the same. So we get 4m plus 10 equals 6m, and we subtract 4m, 10 equals 2m, divide by 2, and m equals 5. Bada bing, bada boom. Okay, let's go on to example 4. Okay, so on example 4, it says, if the perimeter of triangle ABC is 30, what is the perimeter of XYZ? It says, use the diagram from example 3. So we're using the diagram, but we're like starting over. It's like a new problem. So we're going to ignore whatever we did in example 3. So the perimeter of ABC is 30. So we can say that AB, side segment AB, oopsie, I don't want to use the line over top of it, just the distance, plus BC plus AC equals 30, right? And we know that the perimeter of triangle XYZ is going to be 2 of AB plus 2 of BC plus 2 of AC. And so really you could, I want you to just see the algebra. 2, let's take out a common factor, 2 times AB plus BC plus AC. And so guess what we can do? We can just substitute 30, and we get 2 times 30 equals 60. So we know the perimeter of XYZ is 60. Okay, example 5. Let's take a look at it. It says exactly one of the values A, B, or C can be determined. Find which one. Okay, well, let's look at what we know. Let's look at the clues. We see that there's 2 segments here that are both 7, so if those are congruent, we know this is a midpoint. And then these 2 segments are the same, so we know this is a midpoint. However, on this side, 6 and 8, those are different, so we know it's not a midpoint. So we know this line segment right here, B, is a midsegment. We know it is a midsegment, and the reason we know that is because it connects 2 midpoints. Okay, so since it's a mid-segment, we know that the measure of B, this is the one that we can determine, the measure of B is going to be exactly half of its corresponding side. And here's the corresponding side over here, and that has a measurement of 14, and so 14 divided by 2, we know that B equals 7. Okay, now the last part of your lesson you can see on your page. This is something for you to practice on your own. Let's take a look at it real quick. Okay, it says construct the following segments. And when we construct segments, what do we use? We use a compass. So you're going to need to practice to do these constructions. So the first thing says to construct an altitude. So remember, an altitude is goes from a vertex, and it's just a right angle down to the other side. So what we would do on this is you have a point, there's your point, and then you're going to take your compass and you're going to set it a little bit below the bottom of this line, and you're going to swing an arc. And that way you get these 2 reference points. Then use your compass to swing arcs down here and then you'll have a perpendicular that's to a point outside the line, above the line. Okay, so that's how you're going to do that one. And in the same way, we're going to do an altitude over here on this one on the right. So the first thing you want to do is extend this line with your straight edge. Then take this point, here's your reference point, set your compass a little below the line, and you're going to swing an arc to get two reference points right here and right here. And then once you do that, you swing arcs down like this, you connect it up, and you'll have your perpendicular like that. See, isn't that exciting? And then you're going to do an angle bisector. We did these in class. So on an angle bisector, you find your vertex, you swing an arc here, and then that provides you with this reference point and this reference point, and then we swing arcs out here, get the intersection, and then create the angle bisector. A perpendicular bisector, remember we did these in class the other day too, so we're going to get our points, set your compass a little more than halfway, you got arcs like this, you connect them up, and you got your midpoint, which is also perpendicular bisector. Okay, so bada bing, bada boom on that. Okay, and then let's see here, median. To get the median, you have to get the midpoints of two different segments. So we can find the midpoints again by going like this and finding 2 points, and there's going to be your midpoint. And same thing over here, we would get 2 arcs like this, and there's your midpoint. So that would be able to oh my goodness, I just did that. That was mid-segment. Okay, that was mid-segment. Sorry. Okay, the median, on the other hand, just shoot me in the head. Okay, we'll do the median over on this one. The median, you need to get the midpoint, so you do have to find your midpoint by bisecting it. And then once you have your midpoint, then you just draw a line from the opposite vertex down. So on that one, your median is not necessarily perpendicular. Okay, it just goes from the vertex down to the midpoint. Okay, so you need to practice those with your compass and start getting pretty comfortable with the compass. Okay, so that's your lesson. I hope you have a good weekend. I'll see you Monday. Bye.